Okay, this is Algebra 1. Oops, that's not a very good color to use, is it? This is Algebra 1, problem 19 on section, I believe it was 9.2 that was asked. And I'll probably put some more on here if I can. So number 19, section 9.2, this is on page 419. Okay, so here's the problem. We're supposed to solve, and here's our system. 2u plus v is equal to 9, and u divided by 2 minus a half is equal to negative v. Okay. Now the first thing I notice about this is we almost have something by itself. We almost have a v by itself. It's just a negative. So let me come over here and play with this equation for a minute. Well, the problem is well, you know what, I was going to do something that's probably not a good idea. Let's talk about the fractions first. That would probably be the best way to look at this. If I have fractions and I don't like them, 2 and 2, I could get rid of them. If I multiplied every single thing in the equation by 2, that would get rid of the fractions. If it had been 2 and 3, I would say 2 times 3 is 6, multiply everything by 6. Sorry, by 6. Here, if I multiply everything by 2, look what happens. Those cancel out, leaving me with u. Those cancel out, leaving me with a minus 1. And then over here, I have minus 2v. Now, I'm looking for one of these. First of all, that got rid of the fraction. So now I can actually say, ooh, I'm not even going to think about that one anymore. This one has turned into u minus 1 equal negative 2v. Now, those look like normal equations, so it's a little less scary for us once we get rid of the fractions. Remember, you can always look at your denominators and decide what could I multiply through that would cause, and remember, you just got to do it to every term, that would cause that fraction to go away. And if I multiply everything by 2, abracadabra, they disappeared. I just got to remember to hit every single term. It's easy to forget the one on the right over here that ended up being negative 2v. All right, now, I've got these two equations, and I know that I need to get one variable by itself. Since we're messing with this equation anyway, why don't we just do this one? Let's get u by itself. If I get u by itself, I could just add 1 to both sides, and u would be, I could write negative 2v plus 1, but I'm going to write 1 minus 2v just because I can, and I don't like negatives out front. Nothing wrong with them, it's just I don't like them. So since I used this equation to figure out what I'm going to substitute, I'm going to go to the other equation, which is 2u plus v. I'll write it in black since it's up there in black. And everywhere I see a u, I'm going to take it out, and in its place, I'm going to put 1 minus 2v, and then I got to copy the rest of the equation. Okay. So 2 times 1 is 2. I got to simplify this to solve it, right? 2 times negative 2v would be negative 4v plus v equal 9. Okay, running out of room here. Negative 4v plus v would be minus 3v, wouldn't it? So now I'm down to 2 minus 3v equal 9. I was going to do that on a new page. 2 minus 3v equal 9, and I knew that u was equal to 1 minus 2v. So I'm going to keep that there just because I'm going to use that in a minute. Okay, I need to solve for v over here. Remember, I had substituted. I had used this, and I had substituted, and this is what I had ended up with. So let's solve for v. I'm going to subtract 2 from each side. Negative 3v is equal to 9 minus 2 is 7. And if I want to get v by itself, I divide both sides by negative 3. And I get v is negative 7 over 3. It's not pretty, but it's not the end of the world. Hopefully I haven't miscopied this from one page to the other. I can't go back and look once I've gone to a new slide, or it messes the recording up and I can't post it. So assuming that I copied 2 minus 3v is 9 right up here correctly, and I didn't mess that up, over here I've got what v is. V is negative 7/3. Oh, actually, that is right. I do have the answer book in front of me. I guess I could look. Now what I'm going to do, I need to find u. So to find u, I'm going to go over here, right? Because the last place that I was messing around with you, I got it all by itself. And all I need to do to find it is to plug in my answer for V. Well, my V was right here, wasn't it? Negative 7/3. So I'm going to put negative 7/3 right here. Okay, so we just have to simplify this. 1, okay, I've got a minus 2 times a negative 7/3. I can look at that as a negative times a negative is a positive, and 2 times 7 is 14 on top. Remember, I can put that over 1. 2 times 7 is 14, and on the bottom, 1 times 3 is 3. Let's get a common denominator so we can add these easily. If I want to get a common denominator, and I've got a 3 on the bottom here, I'll need to multiply the 1 by 3/3. So that gives me 3/3 plus 14/3, and that's going to equal 17/3. That's what U is equal to. If you remember, we write our answers as points when we're finding both the coordinates. A lot of the word problems we had, we didn't have to find both quantities because they didn't ask us for both. But here, if I want to write it as a point. And remember, we're going to alphabetize U and V. That's how we're going to know what to put where. My U was actually the 17/3 that was right here. And my V was actually right up here in green. That is how I could write my answer. That's the best way to write your answer. You could write U equal this and V equal this, but it's better to write it as a coordinate point. Let's do another one while I got the video rolling here. Let's look at number 27, just because we didn't do it in class and I kind of half expected somebody to ask about it. The problem is x plus y over 2 is 10, and then the other equation is 2x is equal to 3y. Now I'm looking up there at the top and I don't like it because it's a fraction, so I'm going to clear it up a little bit. So let's go off to the side and mess with this fraction a little bit. I'm going to come over here to play with it. Now I don't know if you remember this, that anytime you have a fraction on one side of the equal sign and I got a whole number on the other, I can make that right hand side a whole number by sticking it over, a fraction, that whole number a fraction by sticking it over 1. So if you remember, how that helps me is I can cross multiply. I can say 1 times x plus y is x plus y, and then I can multiply 2 times 10, and that's 20. Oh, now I've got x plus y is 20. I'll call that equation 1, and then here's equation 2. Now I want an equation where I can get x or y by itself. So if I look at equation 2 over here, they've got numbers in front of them. I'm not real crazy about that. Let's go over here to the equation that I labeled 1. Let's say I decide I want to get x by itself since it's first. Well, I could subtract y from both sides, and I'd get x equal 20 minus y. Okay, when I get done, I know I'm going to need to know what's the x and what's the y. So I'm going to prepare a place to put my answer. It's going to go there when I get done. Now when I have this x equal 20 minus y, that means I go to the other equation, and everywhere I see the x, I'm going to take the x out, and in its place I'm going to replace it with the equal expression 20 minus y. So I have now 2 times 20 minus y is equal to 3y. So I got to simplify this and solve for the variable. The variable's y. Your goal in life in algebra is to get the variable by itself. So that's kind of how we know what we need to do. Solve for y. 2 times 20 is 40. 2 times negative y is negative 2y. And that's equal to 3y. I've got variables on both sides of the equation, so I need to get them on one side, and I really like positive values. So I notice I got a minus 2y on the left, so let me move it to the other side by doing the opposite. Okay, that gives me 40. If I add 2y to both sides, 40 is equal to 5y, and if I want to get y by itself, all I got to do is divide by 5. And I find out that y is 40 over 5, which is 8. Let me put that over here in the coordinate point since I have it. It's 8. Now I'm almost done. I just need to find the x. And I got the y in. Now y is 8, and I need to find x, and look right here. X is equal to 20 minus y. Hey, that's easy to plug in because y was 8. So 20 minus 8 would give me 12 for x. So once I find one of them, it's usually easy to find the other one.